Hello, welcome back to Beneficiary Live Noding. In this episode, I will be doing kind of like a shader study using this post by Erin Dale. So there's this post earlier today by Erin, and this post is showing you this. He said it's very useful to make some kind of blinds opening and closing. So I didn't know this until I tested out and playing with the value, and I kind of wanna test it out myself. And also in the post, Bartek also mentioned you can also use this compare nodes. Okay, so yeah, let's see what's actually going on. So let's get started. I'm just gonna have a plane. We know that a plane already have a UV texture, a 2D for 2D texture placement, and we're gonna look at what's going on using color ramp. So this is the material of this object. We don't care about all this diffuse. We're just gonna plug something into the base color. Usually color ramp is a good one. Just plug this in, and then for the texture coordinate, you can use generate or the UV. I should also use this cube just to give a comparison of what's going on. So file, save as, this is a mask, range mask. So we can, normally it's a good idea to, if you are new, you can try something like this. So from generated texture coordinate, like for example, if you are using generated and plug in the X, and then go into, I just use this viewport shading. So if you are using the X value of this generated texture coordinate, you're gonna have color ramp that goes like this. If you use the Y, it goes in the Y, and use the Z. So yeah, it goes from 0 to 1 in the Z axis. If we are using the UV, it's gonna be using the UV of these objects. And usually for the UV, only the X and the Y will have effects. So you can see the ramp there changing. Okay. So let's do first what Bartek is showing using compare. So using compare, which is under math, we have compare. So we have two values to compare. We have this, let's use the X going there. So there's a epsilon. Suddenly something's start to happen. So we can have this value that's kind of, okay, you can kind of have this kind of animations, right? You remember a movie like Knight Rider? So this is the light that goes on a kit on the car kit, and yeah. So basically, compare kind of like comparing the value of X into this value, and then there's this epsilon. This is actually super handy if you're using multiply. I believe so. Right away I like to play around with this. So with the X and the Y multiply together, you can have that square. Or maybe use add. See? This one's actually a good starting point to create a pattern, to draw a pattern on using shaders, you know. Although it's not 100% clear at first. So that's actually the compare thing actually seems to work. I'm gonna save this, save again as a different blend, and let's try what Erin is doing. So this is what Bartek is doing. This is what Erin is doing. Range mask with a greater than, less than, and multiply. This is not so clear at first, but I'm gonna use SVerchok also to explain this. I think to be more clear what's actually going on. So should I go to SVerchok first, or maybe just stay here first? I guess, yeah. So we have greater than. This is for comparison. All this math is for comparison. Usually the result is true or false if you are using logic. But using shader, you're gonna get a value either 0 or 1, and that 0 and 1 can be used with factor for colorant. So let's do this. So we have a value. We're gonna use the x value. So don't worry about this for now. Disconnect. We're gonna use the same value, UV separated into x and y. Let's use just the x value, and then use the less than. And okay, this is less than, and then the threshold. So there is a value coming in, and we are comparing it with another value, this threshold. So if the value is lower than 0 or lower than the value that's coming in, it's gonna create this kind of like a masking. So that's what Erin is doing. And there's a greater than. So this one is gonna do the opposite. Yeah, so it's doing the opposite. And combining the two using multiply, we're gonna get something that looks like a masking, or yeah. So less than, greater than. I think this is the minimum value, this is the maximum value. We should look at it like this. So minimum, maximum, and there's a value, one value that's coming in. So we so like Erin said, this is super useful, similar to what this compare is doing up there. Since this is so useful, and we might be able to just group it. Select these 3 nodes. We can usually F3 and then just group. Node, make group. We know that this value coming in is actually the same value, so we just use the same slot. So we just need the minimum and the maximum. So we have to rename this to be properly named. So this value, that's correct. This one may be minimum. This one is maximum. So if we go out now, we have this control for minimum and maximum. Save, let's save this. So minimum, maximum. And I believe with Erin one, there's the combination is the input there. So from to, yeah, I think this is correct. I think I renamed this incorrectly. I named this incorrectly, so this should also be minimum. This is maximum. Okay, so that's what it is. And then normally it's a good idea to also change the name, change the property. So this node group, okay, we just name it range mask. So this is something that you can reuse from this group node. So anyhow, that's the shader. I think shader is fine if you can just work in the shader, but normally to understand this even further, I kind of use SVerchok as well. So I'm gonna show it to you why. Because with shader you can't really see the number. With the SVerchok you can. So let's say we have a number range. So in SVerchok you have number range. Maybe it's, okay, this is the original value. You can think of it like the UV between 0 and 1, and you create a vector in. So let me do this for now. So the output is this dots. Just gonna make it the value between 0 and 1. So you can see there's the dots going on there, and I'll just make it between x and we're gonna go to the x and the z axis. Let's do the UV connection so we can see the edges. Okay. So this is the value range of value going from 0 to 10. We can resample it if you like. Let's resample it 50 times. Okay, that's fine. So what's going on with this? What's going on with the shader? It's basically just the logic. Like I said, it's great. It's either we are making this value from 0 to 10 or from 0 to 1, and we are comparing it using logic. So this is less than, right, or greater than. So there's this value that's coming in that we want to compare it with another value, whether it's greater than or smaller than. And the output, because it's in SVerchok, we can see it's a true and false. Let's reduce this to 10 again. You can see this value, true and false. If I scrub this number, it's gonna go either true or false. If it's true, it's white color. If false, it's black color. This is the opposite. And from this value, if we use math and just multiply them together, we're gonna get what's going on with the shader. We can see very clearly very soon. So you can see here, false, 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 true, true, false, false, false. Okay. If I scrub this number, we have the minimum and the maximum. Maybe I should switch this around. So minimum and maximum, and the value that's the value that's gonna come out is gonna be 0 and 1 and 0. So if I use this value and plug this into the z-axis, now you can see it's very clear now. We can control the minimum and the maximum. And this is what's controlling this shader, 0 or 1. And you can also remap it. So I think Bartek actually mentioned that if you use the map range, you can have something that's like this epsilon. Could be pretty handy. So value minimum maximum, and the results is compared with this value. Okay. We don't have this compare in SVerchok, I don't think. But this is what it is. In fact, if you use this as displacement, if you use this shader as displacement, it's gonna displace exactly like, and it's gonna create this kind of surface. So yeah, I think it's really pretty clear now. So true or false, black or white. There's no way to blur this. But this color, this value 0 and 1, black or white, you can change this color and you're gonna have different results. So the color range is super handy on that. So whatever value coming in as a vector between 0 and 1 is gonna change that value into color. So that's basically what it is. So a lot of things with shaders is basically like a value and math underneath, and what you want to have is like a pattern that later can control all these values for metallic, roughness, etc. But normally, I think shader 2D or 3D texture is like a math pattern, something to make a pattern. Like if it's for example if we use modulo, we can repeat the pattern, and sometimes I actually, to understand the shader, I use this SVerchok just to understand what's going on with the value. So that's basically what's going on. Yeah, so a single post by Erin Dale, and then also with help of Bartek, we can really understand what's going on on why we are getting this shader pattern, just simply by plugging in on all this weird parameter, like why are we using generated, why are we using UV or normal, etc. I guess this become much clearer. You can actually use this setup to create a like a box present. Yeah, something like that. Christmas, early Christmas. So I think this epsilon, compare and epsilon thing is very handy. And this range mask also, one from Erin, controlling the minimum and the maximum. Maybe something in between that can control the positions, kind of like offsetting the value. Well, anyway, so that's pretty much it. I think it should be pretty clear now. So hopefully it's useful for you. Let me know what you think, and I'll see you next time. Thank you. Bye.